Welcome to another video tutorial. In this video tutorial I'm going to be going through part 6.2 of this exam question. This part of the question asks us to use the following registers to describe the fetch execute cycle or the fetch decode execute cycle in full sentences. And that's important because it's a 6-mark question, so it's not like I've done here going to be expecting you to write it out in acronyms. It's going to be expecting you to write it out in full and describe it fully. Okay, so firstly, as you can see over here, I've got the fetching part of the cycle in red, I've got the decoding part in blue, and I've got the executing part in green. Let's deal with the fetching part first. So up here at the top I've got the address of the next instruction in the program counter is transferred into the memory address register. This one, the memory address register. And then the address bus is used to transfer this address that's been transferred into the memory address register to main memory. And that's in preparation for our next step here. So for my first mark then, I'm going to say that the address of the next instruction in the program counter is transferred into the MAR, and the address bus is used to transfer the address to main memory. Okay, next I'm going to talk about the fact that the value of the instruction that we're finding the address of here in memory is transferred into the memory buffer register. So the data, the instruction that we're going to be using is transferred into the memory buffer register. The transfer uses the data bus. So using the data bus, the instruction from memory is transferred to the memory buffer register. Okay, the last bit of our fetching part of the cycle is the program counter is incremented. So we have the program counter is equal to the program counter plus 1. And then the instruction in the memory buffer register, which we've just transferred from memory, is transferred into the current instruction register. So I'll just write that in now. Okay, now we're moving on to our decoding part of the cycle. So here we've got the current instruction register is decoded. So our instruction that we've put into the current instruction register is decoded by the control unit. This involves splitting it into the opcode and the operand. Current instruction register instruction that we've put in from the memory buffer register in the previous step is decoded by splitting it into the opcode and operand. Now we're moving on to our executing part of the cycle, and I wouldn't need to put all of these points to get the full 6 marks. But these are just to illustrate all the possible points that you could have. I would put in the one about the status register because it specifically mentions the status register up here, so it would be a good thing to add in to make sure you get all the marks. These 3 points here, you wouldn't necessarily have to put in all of those. So for my first point on the executing, I'm going to say the opcode identifies the instruction to be executed, and then the instruction is executed by the CPU. Okay, and my final point then, I'm going to add in something about the status register. And the status register holds bits indicating the result of the instruction execution. So it could be indicating that there's been an overflow error, or it could be indicating that there's been a negative value where there shouldn't have been as a result of a calculation, anything like that, which indicates the status of the instruction execution. And that's my answer. One thing to note is that if you were actually answering this exam question in a real exam, I would write out the full names of the registers and not just use the acronym, and probably make sure that you are using full sentences. I've just written them in sort of note form here just for quickness and to explain easily, but I would make sure that you are using full sentences because that has been indicated in bold in the question there. Okay, that's the end of this tutorial video. Thanks for watching.